Hey, welcome to the Adventures of Blink. Today we're going to talk about unit testing in Python. Unit testing in general, I think, is a skill that's underutilized kind of across the software engineering industry. I don't see a lot of programmers who are really, really good at making sure that they have solid unit tests. We all sort of fall into that trap of, hey, I got to get this thing out the door. I'm not going to bother with as much testing. And testing becomes a second class citizen, which it absolutely should not. It's a valuable skill, and I think it's important for us to go dig back into some of those fundamentals every once in a while. So I've never really used Python at that level before. I've written a little script here and there. I've done a little bit of work, but I've never really built something that I did solid unit testing around. I'd like to explore that, and so I thought I'd bring you along for the ride, and maybe we can learn together. So let's see if we can get started, shall we? So you can see here we have our application. It's a simple interest calculator, and simple is probably a bad word. It's a very basic interest calculator because it calculates both simple and compound interest. You can see the main function there. It has some stuff in it, and then you can go to interest.py, and you can see the two methods that have been created to actually do the calculations. So let's take a look at what it actually does when it runs. So if I start with just Python 3 main.py, I can get two values back. So if I put in 100, 1.05, and 3, these are the values that return in both cases. You can see, of course, compound interest is more valuable over time than simple interest is. Little finance note, you want to keep track of that because compound interest is the most powerful force in the universe. But we're not here to talk finance today. We're just talking about how code works. So there's what actually runs in my Python environment. So what I'd like to do next is set up some testing to validate that those methods work the way I expect them to work. So let's go first. The first thing you would have to do if you were building this from scratch is to install some things. So you need to install PyTest and coverage, and these are going to come back as already installed for me. You won't get to see the full installation process because I already had them in my environment. You'll also notice I'm using virtual environments. Make sure that you do that so that you don't have a huge mess of libraries that are all just piled together and interacting with each other in strange ways. Venv is your friend. It's a powerful way to make sure that everybody's in their own space. So there you have it. Like, those are the things you would need to install. And the next part is just getting started with actually writing your tests. So I've got a test folder that I've created here, and I'm going to add in a file. So test underscore signifies to Python that this is going to be a test file so that PyTest picks it up and runs it automatically whenever I tell it. So I do test, and then I'm doing interest.py because that's the module that I'm testing, and there's our file. So this is what's actually going to be picked up by PyTest when I tell it to run all the tests. First thing we have to do is from, and then I need to go over to the app and pull in interest, and I do import simple interest and compound interest. I want both methods into my test file so that I can use them both to do stuff. All right. So the next thing I'm going to do is I'm going to define my first test. So I'm going to do test of simple interest. Okay. Now, in order to test this, the first thing I'm going to test is that I'm asserting, let's see, and I want to call the method. So simple interest 100, 1.05, 3 responds with what value? It was 3.15. So that's what I'm going to get back. Okay, that sounds fantastic. The next thing that I'm going to test, I'm going to open up a thing that's going to test the compound interest method. And I'm going to do, oops, I almost typed it twice there. All right, 100, 1.05, and 3. Okay, and that should equal this other number, 3.18, blah, blah, blah. Now, I'm not sure if Python's going to like that because of the rounding. We'll see exactly how it works out in the execution of it. So there's my basic unit test for these two methods. I want to test that I put in these values and I get out the results that I expect. So in order to run them, I just come down here and I type PyTest. And PyTest is going to find everything that's marked as a test, so anything that starts with test underscore, and it's going to run that file and give me back the results. And you can see that my tests both passed in this case. Fantastic. I managed not to do them without fouling anything up, and that is not a rounded number. That's the actual value, so I was able to compare against it correctly. That's great work. The next thing about this, though, is really incumbent on the programmer, isn't it? Because I want to test some other features of it. So what does it look like if I put in a negative value for this? What happens? Well, I'm going to come back here and I'm just going to run this to see what happens. So we're going to do negative value equals, and I'm going to do simple interest first. We'll do 100, and we're going to do negative 1.05 and 3. And so then we'll print, and I'll do the same thing here that I had. I'll just type simple negative for that, and we'll do negative value. All right. Now, just for giggles, let's see what happens if I run the program. And it's very simply going to give me back the negative version of that because it's just doing a multiplication. And so when you multiply by a negative number, you get a negative number. All right. But is that the behavior I actually want my app to have? Well, for now, I'm not going to try to resolve it all. So all I'm going to do is I'm going to test the case where I pass in a negative number. And so if I run PyTest again, you'll see I still have two tests because I haven't done anything separate, but they're still passing. So both of those conditions are true. Now let's say that I was building this and I wanted to eliminate the possibility that somebody could give me a negative number there. So if it was going to be passed in as a negative, I would respond by updating it with the positive version of it. So just to see what that looks like, we're going to change that value, and let's see what a failed test runs like. Ooh, lots of bright red on the screen. So you can see there that it has asserted that negative 3.15, which it was using this line of code. You can see it's got it tagged there. It says this came back as negative 3.15, and I was expecting 3.15. And so there's what a failed test would look like in this case. That's a valuable thing to know. And then there would be questions of what happens if I do other things. So one of the real values of unit testing is to validate what happens if somebody just comes back with really wonky results. Like what happens if I do weird value equals simple interest, and I'm just going to do turnip and 1.05 and 3. What happens to the code wow, I cannot type today. I do that. So what happens if I try to do 1.05 interest on a word? I don't know how that's going to react, but let's go see what the code looks like. And I get an error. So in that case, I'm probably safe and I wouldn't have to unit test against it. But if for some reason that didn't just error out, I would want to make sure that I had another case in my test that took care of that problem for me, so that I would know what to track and I would know how it behaved. This could be really important if you were doing a lot of error handling in your code, rather than just letting it drop out to the interpreter. If it's throwing exceptions that are then handled by the code and fails gracefully, you want to make sure that any of those things are actually tested in your process. So the last thing we're going to cover here is how to do coverage. Funny how that worked out. Coverage is a really important concept because you want to know whether your unit tests have effectively covered your code or not. It doesn't do any good to write a unit test that covers 1% of your code and the rest of it is just flying blind. That could still lead to a really bad situation and it doesn't help you at all. So coverage is a stat that we track often. And the way you run a coverage report in Python is to do coverage run-m and PyTest. And so it runs that, and you would see over here this coverage file gets created. That's not openable by your editor. It's a binary file where the data gets stored. But in order to see what happens, you write coverage report in here, and it's going to create a pretty printed version of that. So you can see here are the modules or the Python files within my project. You can see that there are 6 statements in interest.py and there are 6 statements in testinterest.py, and coverage is 100%. So in this case, I managed to cover all of my code. Now that's not always the truth. Sometimes you'll find like boilerplate code and things like that that don't necessarily have to be tested in order to have a complete picture, and they can become clutter if you're not careful. So it's important not to become too pharisaical about it and insist on 100% coverage in every case. You do what makes the most sense and what you get the most value from. So that ROI calculation is really important, just to people in general. Keep that in mind as you build. So there you have it. We've built a unit testing suite using PyTest for our Python application. We've validated that the code is doing what we expect, and we've also run a coverage report to ensure that we have covered as much of our code in testing as possible. There's a lot of valuable stuff in there. It's time to take that and go do some powerful magic in your own work. I hope you've enjoyed the experience. I hope you've learned from it. I know I have. Looking forward to seeing you again here on the Adventures of Blink. Make sure that you like and subscribe, and we'll see you around soon with another project. Happy coding!